Now we're going to be looking at ways to use exponents, and we're going to kind of bridge off of the basic idea of exponents, and we're going to be talking about scientific notation. So this is just one little part of another topic that uses exponents frequently. So I want you to go ahead and pause if you need to and write down the standard form definition and scientific notation, and then when you're ready, go ahead and continue the video. So standard form is a number written in the way most commonly accepted. So when we talk about age, if you say I'm 12 or I'm 13, we just write 12 years old or 13 years old. We don't have any fancy mathematical way of writing it. We just say 12. Or the number of items. I have 25 books on my shelf. There are 30 seats in my classroom. So number of items, things that we use commonly, are just expressed with numbers. So we consider that standard form. However, some of our numbers get really large or really small. So here's a couple numbers I just wrote down on a scrap piece of paper. And I just quickly Googled how many miles it is from the Earth to the Sun, and it said 92.96 million. So I wrote that number all the way out. So this is how many miles it takes to get from the Earth to the Sun. Well, that's pretty commonly used. We're talking millions, but it takes a long time to write down. There's a lot of zeros there. And then I decided, okay, let me convert that to feet, because there's 5,280 feet in a mile. Well, then I got this really big long number. So for really large numbers and some really small numbers, so I looked up the size of an atom, and it said it averages between 0.1 nanometer to 0.5. So it's 0.0000, all of these zeros, 1 meter, or this many meters. So again, we're taking very large or very small numbers, and scientific notation allows us to take really big numbers or really small numbers that have a lot of zeros typically and write them in a more condensed version. So this right here, 2.31 times 10 to the 5th, that is a condensed version of something really big, okay? So scientific notation is written this way. So the first number, it's typically a decimal between 1 and 10. So you can get as high as 9.9999999, but we wouldn't actually use the number 10. So it has to be between 1 and 10. And then we pick that decimal and we say times 10 to a power. Now, the reason why we're doing 10 to the power, and I'm going to show you how to do this, is if we look at just a number, this one is in the ones place, the next digit over is the tens, the hundreds, the thousands, the 10,000s, the 100,000s, the millions, 10 million, 100 million, and then the cycle just keeps repeating. Well, every time you go from one spot to the next, so as you are like counting over, some will say sliding over or drawing loops, you're going to increase by 10. So the ones times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. Times 10 is 100, and so on. So the reason why we use a power of 10 is because you're telling them that you're moving over this many places, okay? By powers of 10. Now, if this exponent right here is a positive exponent, you're going to have a very large number, like traveling from the Earth to the Sun. So a positive exponent means that you're going to have a large number and you're going to move to the right. So if I see a positive 5, it means I'm going to move 5 to the right. If I see a negative number, so for example, let's just write down 1.87 times 10 to the negative third. If we see a negative number, okay, a negative exponent, we're going to get a small number, like the size of the atom, and we're going to move to the left. So here's how this is going to play out. This is what it's going to look like. So this number right here, I notice that it's positive, So that means we're going to move 12 places to the right. So again, when I mean places, we've got to figure out how many places we are going to be. So what you do is you take your decimal, 5.2, we're going to count 12 places to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, all of these loops you have to fill in with zeros. Now, it's not 12 zeros, okay? Because my first loop had a 2 in it. So don't just add 12 zeros. You're moving 12 places over. One place was already occupied by a number, so I actually only needed to add 11 zeros. So this number in scientific notation is really this number, 6, 7, 8, 9, 10, 1, 2, 3. Let me put my commas in. 1, 2, 3, 1, 2, 3, 1, 2, 3. This scientific notation number is really this in standard. So this is what we consider standard form. Okay? And this is scientific. So you can see, rather than writing out all these zeros and taking up this much space in my paper, I can write it into a condensed spot and only take up this much paper. Now, if you see a negative exponent, right here, if this is negative, we're going to move to the left. This is a really small number. So we're going to take our decimal, 1.34, and we're going to go 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Again, we need to fill in any empty loops with zeros, but be careful, it's not 8 zeros. The first one was filled with the number 1. So this is really point, and then I have 1, 2, 3, 4, 5, 6, 7, only 7 zeros. 1, 2, 3, 4, 5, 6, 7, 1, 3, 4. Now, some students don't like to just leave this decimal here. You can just write it like this. Some like to put a 0 in front, but this 0 had nothing to do with the -8. It's just kind of a placeholder. So this is standard form, and this was the scientific. So again, what we're trying to do, scientific notation, we are going to try to write very large numbers or very small numbers in a condensed way. So we can take a scientific number and write it out standard form, or shortly I'm going to show you how to take a standard form and convert it into scientific notation.